Here is something to hold in your mind as you drift towards sleep tonight. If you were to drain every ocean on Earth and stand at the bottom of the deepest point, a place called the Challenger Deep in the Mariana Trench, you would be standing nearly 7 miles below where the surface of the water once was. Mount Everest, the tallest mountain on land, could be placed at the bottom, and its peak would still be more than a mile beneath the waves. The ocean is not simply large, it is almost incomprehensibly deep. It covers 71% of our planet's surface. It holds 97% of all the water on Earth. It is home to the largest animal that has ever lived. It produces more than half the oxygen in every breath you take. It regulates the temperature of every place on Earth, including the room you are lying in right now. The ocean is not just a feature of our planet. In many ways, it is the reason our planet is alive at all. Tonight, we are going to drift through it together, slowly, gently, from the sunlit shallows where coral gardens grow, to the soft dark of the open sea, to the quiet midnight zone where creatures carry their own light through the dark. There is nowhere more vast, more ancient, or more quietly alive than the ocean. Let your body settle. Let your breathing slow. The water is warm. The current is gentle. We begin. Before we enter the ocean, let us consider water itself, because water is one of the most extraordinary substances in the universe, and the ocean is made of almost nothing else. A water molecule is almost absurdly simple. 2 hydrogen atoms bonded to 1 oxygen atom. 3 atoms. And yet, the properties of this tiny molecule are so unusual, so perfectly suited to supporting life, that some scientists have described water as the universe's most important accident. Most substances contract when they freeze, becoming denser as they become colder, sinking to the bottom of whatever they are in. Water does the opposite. As it cools toward freezing, it reaches a point of maximum density at 4 degrees Celsius and then begins to expand. When it freezes, it becomes less dense than liquid water and floats. This seemingly small quirk has enormous consequences. Because ice floats, frozen bodies of water form a layer of insulation on their surface, protecting the liquid water and the life within it from the cold above. If ice sank, as most frozen substances do, bodies of water would freeze from the bottom up, and aquatic life as we know it could not exist. The ocean would be a very different place, perhaps no place at all. Water also has an extraordinary ability to absorb and hold heat, a property called specific heat capacity. The ocean acts as a thermal battery for the entire planet, absorbing heat from the sun during the day and releasing it slowly at night and through the seasons. Without the ocean's capacity to hold heat, the surface temperature of the Earth would swing wildly between extremes. Too hot during the day, too cold at night for most life to survive. The steady, moderate climate that allowed civilization to develop, that allowed you to be alive and lying in a comfortable bed tonight, is, in large part, a gift of the ocean's ability to absorb and redistribute warmth. Water molecules are also strongly attracted to each other, a property called cohesion. This attraction creates surface tension, the force that allows small insects to walk on water and causes water to bead up on a leaf. But more importantly for the ocean, cohesion means that water can be pulled upward through the vessels of plants, defying gravity, carrying nutrients from roots to leaves. Without this property, trees could not grow tall, forests could not exist, and the land would be a very different place. The ocean is made of water, and water makes almost everything possible. The ocean is never still. Even in the deepest, darkest places, far from any wind or storm, the water moves. The surface of the ocean is driven by wind. As air moves across the water, it transfers energy to the surface, pushing the top layer of water forward in the same direction. This creates currents, rivers within the ocean flowing along established paths that have remained largely constant for thousands of years. The most well-known of these is the Gulf Stream, a powerful current of warm water that flows northeastward from the Gulf of Mexico across the Atlantic toward Europe. The Gulf Stream carries more water than all the world's rivers combined. It is the reason that London and Paris, which sit at roughly the same latitude as parts of Canada, have mild winters rather than Arctic ones. The warmth of the American tropics flows across the Atlantic and warms the air above northwestern Europe. The ocean gives Europe its climate. But beneath the surface, currents lie something even more extraordinary: the deep ocean conveyor belt. This is a global system of circulation driven not by wind, but by differences in water temperature and salinity. Cold, salty water is denser than warm, fresh water, and so it sinks. In the North Atlantic, surface water cooled by Arctic winds becomes dense enough to sink thousands of meters to the ocean floor, where it begins a slow journey southward and eventually eastward, spreading through all the world's ocean basins. This deep circulation takes approximately 1,000 years to complete a full cycle. Water that is sinking in the North Atlantic today will not return to the surface until roughly the year 3025. The ocean moves on timescales that dwarf human history. Waves are a different kind of motion, not the movement of water itself, but the movement of energy through water. When you watch a wave roll toward shore, the water itself is not traveling with it. The water molecules move in small circles as the energy passes through them, returning almost to where they started once the wave has gone. It is the energy that travels, not the water. The wave that breaks on a shore may have been born thousands of miles away from a storm far out at sea, its energy traveling across the entire width of an ocean before finally spending itself on a distant beach. Tides are perhaps the most gentle and consistent of the ocean's movements. They are caused by the gravitational pull of the moon and, to a lesser extent, the sun, on the Earth's oceans. As the Earth rotates, different parts of the ocean move closer to and further from the moon, and the water bulges slightly toward it, creating the slow, reliable rise and fall of the tides. The tides have been rising and falling for as long as the moon has circled the Earth, roughly 4.5 billion years. Every creature that has ever lived on a shoreline has known the rhythm of the tides. It is one of the oldest rhythms on Earth, as reliable as the turning of the planet itself. The ocean is divided into zones based on how much light reaches them, and the uppermost zone, the sunlit zone, or euphotic zone, is where almost all of the ocean's photosynthesis happens. The sunlit zone extends from the surface down to about 200 meters. Light penetrates this layer fully enough for photosynthesis to occur, and it is here that the ocean produces the majority of its oxygen and supports the base of almost all marine food webs. The primary producers of the sunlit zone are phytoplankton, microscopic, single-celled organisms that drift in their billions through the upper ocean, capturing sunlight and converting it into energy through photosynthesis. They are invisible to the naked eye, yet they produce between 50 and 80% of all the oxygen on Earth. Every other breath you take was made by the ocean. Phytoplankton are so small that a single drop of seawater can contain thousands of them. They come in extraordinary shapes, spirals and stars, chains and discs, each species with its own architecture, its own way of catching light and staying afloat. Under a microscope, a drop of ocean water looks like a miniature cosmos, filled with strange and beautiful forms. When phytoplankton populations bloom, as they do seasonally in response to warming temperatures and nutrient upwellings, they can be seen from space. Vast swirls of blue and green spreading across the ocean's surface, visible in satellite images as brushstrokes of color on the water. The ocean blooms like a garden. In the sunlit zone, the water itself filters light as it travels downward. Red wavelengths are absorbed first, within the top few meters, which is why underwater photographs taken without artificial light shift quickly toward blue and green. By 20 meters, red has almost entirely disappeared. By 100 meters, only blue light remains, filtering down in soft, shifting columns through the water above. Divers in the sunlit zone describe the quality of light as unlike anything on land, a soft, diffuse, all-surrounding blue that filters and shifts as the surface moves above. Shadows are not sharp but gentle. Light moves in slow, drifting patterns on the sandy bottom. Everything feels suspended, cushioned at rest. The ocean holds light the way sleep holds the mind, gently, softly, transforming it into something altogether quieter. In the warm, shallow waters of the tropics, where sunlight reaches the sea floor and the temperature is just right, coral reefs grow. A coral reef is one of the most biologically rich environments on Earth, home to an estimated 25% of all marine species, despite covering less than 1% of the ocean floor. They are, in a very real sense, the rainforests of the sea. But a coral reef is not a rock. It is an animal, or rather millions of animals, living together in one of the most extraordinary cooperative arrangements in biology. Each coral polyp is a tiny animal, related to jellyfish and sea anemones, with a soft body and a ring of tentacles surrounding a central mouth. The polyp secretes a hard calcium carbonate skeleton around itself for protection, and over years and decades and centuries, these skeletons accumulate layer upon layer, building the complex three-dimensional structure of the reef. A large coral reef, like the Great Barrier Reef off the coast of Australia, took thousands of years to build. The Great Barrier Reef itself began forming around 20,000 years ago. It is the largest living structure on Earth, stretching more than 2,300 kilometers and visible from space. But the coral polyp does not work alone. Living within its tissues are microscopic algae called zooxanthellae, tiny photosynthetic organisms that have taken up residence inside the coral in a relationship of extraordinary mutual benefit. The zooxanthellae photosynthesize, using sunlight to produce sugars that the coral consumes. The coral, in return, provides the algae with shelter and the carbon dioxide they need for photosynthesis. Up to 90% of a coral's energy comes from its resident algae. The coral is, in a sense, a solar-powered animal. The colors of a coral reef, the vivid yellows and purples and greens, come largely from these resident algae and from the pigments the corals themselves produce. A healthy reef is a riot of color, every surface covered in life, every crevice occupied by something. A fish, a shrimp, a worm, a sponge, a sea star going about its quiet business. Fish navigate the reef using a combination of vision, smell, and an ability to detect electrical fields. The cleaner rasa, a small fish found on reefs throughout the Indo-Pacific, has established cleaning stations, specific spots on the reef where larger fish come to have parasites and dead tissue removed from their skin, gills, and even the inside of their mouths. The large fish signal their wish to be cleaned by adopting a specific posture, hovering motionless with fins spread. The cleaner rasa moves over their skin with delicate, precise movements. And the large fish, which could easily eat the small cleaner, holds completely still. Trust on a coral reef. Beyond the reef, beyond the continental shelf, the ocean opens into something vast and blue and largely empty. This is the pelagic zone, the open ocean, and it covers more of the Earth's surface than all the land combined. Life in the open ocean has no solid surface to cling to, no reef or rock for shelter. Everything here must either swim, float, or drift. And the creatures that have evolved to live in this environment are some of the most remarkable on Earth. The whale shark is the largest fish in the ocean. Not a whale, despite its name, but a true fish, a member of the shark family. It can grow to 12 meters or more in length, weigh as much as 20 tons, and yet it feeds almost exclusively on the smallest creatures in the ocean: zooplankton, fish eggs, and tiny fish. It moves through the water with a slow, unhurried grace, its enormous mouth open, filtering hundreds of thousands of liters of water per hour. There is something deeply calming about the whale shark, something about its size, its gentleness, its slow passage through the blue. It seems to carry the patience of the ocean itself. The blue whale is even larger, the largest animal known to have ever existed on Earth. A full-grown blue whale can reach 30 meters in length and weigh up to 200 tons. Its heart is the size of a small car, beating just a few times per minute. Its aorta, the main vessel leading from the heart, is wide enough for a small child to crawl through. A blue whale breathes air, as all whales do, surfacing every 10 to 30 minutes to exhale through its blowhole. The spout of a blue whale can reach 9 meters into the air. Blue whales communicate through low-frequency calls, the lowest sounds produced by any animal on Earth. These calls travel through the ocean at the speed of sound in water, about 1,500 meters per second, roughly 5 times faster than sound travels through air, and can be detected by other blue whales hundreds, sometimes thousands of kilometers away. Right now, somewhere in the deep ocean, blue whales are calling to each other across distances that dwarf entire countries. Their voices move through the dark water in slow, deep pulses, carrying across the ocean like a heartbeat. The ocean has always had this music in it. Sea turtles cross the open ocean on journeys of thousands of kilometers, navigating by the Earth's magnetic field, sensing the slight variations in magnetic intensity and inclination that form a kind of invisible map across the ocean's surface. A loggerhead sea turtle hatched on a beach in Florida will spend years wandering the Atlantic, following currents and magnetic contours before returning, years later, to nest on the same stretch of beach where it was born. It finds its way home across an ocean using a sense we do not possess, to a beach it has not seen in years, guided by the magnetic memory of the place where it first entered the sea. Below the sunlit zone, the light begins to fade. From 200 meters to roughly 1,000 meters below the surface lies the mesopelagic zone, the twilight zone. Here, sunlight is present but too dim for photosynthesis. The water is cooler, the pressure greater, the darkness deepening with every meter of descent. The twilight zone is one of the largest living spaces on Earth and one of the least explored. It is estimated to contain more fish biomass than all the world's surface fisheries combined. Vast, shadowy schools of small fish and squid that spend the day in the cool dimness of the twilight zone and rise toward the surface each night to feed. This daily migration, called the diel vertical migration, is the largest animal migration on Earth, and it happens every single day in every ocean, largely unseen. As darkness falls at the surface, billions of creatures rise from the deep, a living tide moving upward through hundreds of meters of water in a matter of hours, feeding on the phytoplankton and zooplankton of the sunlit zone, then descending again before dawn. In the twilight zone, bioluminescence becomes common. Many of the creatures that live here, fish, squid, jellyfish, shrimp, produce their own light through a chemical reaction involving a molecule called luciferin and an enzyme called luciferase. When luciferin reacts with oxygen in the presence of luciferase, it produces light without heat. Cold light, efficient light, light produced for communication, camouflage, and hunting. Some twilight zone fish use bioluminescent lures to attract prey. Some use patterns of light on their bodies to match the faint downwelling light from above, making themselves invisible to predators looking up from below. Some use flashes of light to startle or confuse attackers. The hatchetfish is one of the most extraordinary residents of the twilight zone. It has enormous, upward-facing eyes, evolved to detect the silhouettes of prey against the faint light filtering down from above. Along its belly runs a row of bioluminescent photophores that produce light exactly matching the intensity of the downwelling sunlight, making the fish effectively invisible from below. It is wearing a cloak of light. At night, when the hatchetfish rises toward the surface to feed, it moves through water that is almost completely dark. The surface above it blazes with stars. Below it, in the depths it came from, other creatures are producing their own cold constellations. The ocean at night is full of stars. They are just underwater. Along the cold, nutrient-rich coastlines of the world, the western coasts of North and South America, southern Australia, South Africa, parts of New Zealand, there grow forests unlike any on land. Kelp forests are among the most productive and biologically diverse ecosystems on Earth. The kelp itself is not a plant, but a brown alga, a photosynthetic organism that can grow up to 60 centimeters per day under ideal conditions, reaching heights of 45 meters or more. A mature kelp forest looks from below uncannily like a terrestrial forest. The kelp rises in great columns from the seafloor, its broad blades catching the light, its canopy filtering the water above into shifting green and gold. Schools of fish move through the columns like birds through trees. Sea otters wrap themselves in kelp fronds to anchor themselves while they sleep on the surface, rocking gently in the swell. The sea otter is one of the kelp forest's most important inhabitants, not despite being a predator, but because of it. Sea otters eat sea urchins. Sea urchins, left unchecked, eat kelp. A thriving sea otter population keeps sea urchin numbers in balance, allowing kelp to grow and the forest to flourish. Remove the otters and the urchins multiply, devouring the kelp until nothing remains but a barren, rocky seafloor. The sea otter is what ecologists call a keystone species, a species whose presence or absence determines the structure of an entire ecosystem. The kelp forest exists in large part because the sea otter exists. This kind of interdependence, one species holding the balance of an entire community, is everywhere in the ocean. Nothing lives in isolation. Every creature is part of a web so intricate and so tightly woven that pulling on one thread changes the pattern of everything else. Garibaldi fish, vivid orange against the green of the kelp, are among the most territorial residents of the kelp forest. A male Garibaldi will spend weeks carefully preparing a nest of red algae on the seafloor, tending it obsessively, removing any unwanted material with his mouth, grooming it into exactly the right texture to attract a female. When a female arrives and lays her eggs, he guards them ferociously until they hatch, fanning them with his fins to keep them oxygenated, chasing away anything that comes close. A fish, tending a garden, waiting for his family to be born. Below 1,000 meters, the last trace of sunlight disappears entirely, and the ocean becomes a place of perpetual darkness, crushing pressure, and near freezing temperatures. This is the bathypelagic zone, and below it, the abyssal zone. Depths that were once thought to be completely lifeless, so hostile were the conditions believed to be. They are not lifeless. They are teeming. The pressure at the deepest points of the ocean is more than 1,000 times the atmospheric pressure at the surface, enough to crush an unprotected human body. Yet creatures live here in abundance. Fish with flexible bones and soft bodies, shrimp with transparent shells, sea cucumbers moving slowly across the seafloor, filtering sediment for organic material, giant isopods, distant relatives of the pillbugs you might find under a rock in your garden, crawling through the dark. The deep ocean floor is covered in a fine, soft sediment called marine snow, a continuous, gentle fall of organic particles drifting down from the waters above. Dead phytoplankton, fecal pellets, fragments of decaying animals, all of it drifting slowly downward, taking weeks to settle from the surface to the deep sea floor. This marine snow is the primary source of food for most deep-sea creatures, a slow, continuous rain of nutrition falling from the sunlit world above. Creatures of the deep ocean have evolved extraordinary adaptations for life in the dark. Many are bioluminescent, producing light for communication and hunting. Many have very large eyes to detect the faintest traces of light. Some have no eyes at all, having evolved in environments where vision serves no purpose, relying instead on exquisitely sensitive detectors of pressure and chemical signals. The anglerfish is perhaps the most famous deep-sea creature. A fish with a bioluminescent lure dangling from its forehead like a fishing rod, attracting prey in the darkness. The female anglerfish, which can grow to 20 centimeters, has an enormous mouth lined with long, translucent teeth and a stomach that can expand to accommodate prey larger than itself. But it is the male anglerfish whose life is the most remarkable. Born without a lure, without a functional digestive system, the male's entire existence is oriented toward one purpose: finding a female. When he does, he bites into her skin and fuses with her body. His circulatory system connects to hers. Over time, his body is absorbed into hers until nothing remains but the testes, permanently attached to the female, providing sperm whenever she needs it. In some species, a single female may carry several males fused to her body. The deep ocean finds its own solutions to every problem. Hydrothermal vents are among the most extraordinary features of the deep ocean floor. Where tectonic plates spread apart, seawater seeps down through cracks in the seafloor, is superheated by the magma below, and rises back up through chimney-like structures, carrying dissolved minerals. The water emerging from these vents can reach temperatures of 400 degrees Celsius, yet it does not boil because the pressure at these depths is so extreme. Around hydrothermal vents, entire ecosystems exist without any sunlight at all. The primary producers here are not photosynthetic organisms, but chemosynthetic bacteria. Organisms that derive their energy not from light, but from the chemical energy in the hydrogen sulfide and other compounds venting from the seafloor. These bacteria form the base of a food web that includes tube worms 3 meters long, giant white clams, crabs, shrimp, and fish, all thriving in total darkness miles below the surface, sustained entirely by the heat of the Earth's interior. Life needs sunlight to exist, except when it doesn't. The ocean and the atmosphere are not separate systems. They are one system, exchanging gases, heat, and water in a continuous ancient conversation that shapes the climate of every place on Earth. The ocean absorbs carbon dioxide from the atmosphere. Roughly 25% of all the carbon dioxide humans release each year is absorbed by the ocean. It dissolves into the surface water, where some of it is used by phytoplankton for photosynthesis, and some of it sinks into the deep ocean where it may remain for thousands of years. The ocean is the largest carbon store on Earth after the rocks of the Earth's crust, holding roughly 50 times more carbon than the atmosphere and 20 times more than all the world's land plants and soils combined. Without the ocean absorbing carbon, the atmosphere would contain significantly more of it, and the planet would be considerably warmer. The ocean also produces oxygen, vast quantities of it, every second of every day, through the photosynthesis of phytoplankton in the sunlit zone. This oxygen dissolves into the surface water and is released into the atmosphere. Every second breath you take, roughly, was produced by the ocean. Water evaporates from the ocean's surface continuously, driven by the heat of the sun. This water vapor rises into the atmosphere, condenses into clouds, and falls as rain and snow over land. The water cycle, which fills rivers, replenishes groundwater, waters forests and crops and everything that grows on land, is powered by the ocean. The rain that falls on the mountains, the rivers that carry it to the sea, the clouds that form over the ocean and drift over the continents. All of it is the ocean, moving through the sky. Tropical oceans generate hurricanes and typhoons, enormous spiral storms fed by the heat and moisture of warm ocean water. These storms are destructive near land, but in the open ocean, they play an important role in redistributing heat from the tropics toward the poles, cooling the warm equatorial ocean and warming the colder waters of higher latitudes. Even the most powerful storms are part of the ocean's system of balance. The ocean breathes with the seasons. In spring and summer in the northern hemisphere, phytoplankton bloom in enormous quantities, absorbing carbon dioxide from the atmosphere. In autumn and winter, the blooms die back, and some of that carbon is released again. Scientists monitoring the carbon dioxide concentration in the atmosphere can see this seasonal breathing. The slight dip in summer as the ocean inhales, the slight rise in winter as it exhales. The ocean breathes once a year on a global scale, and we can measure it. Before we rest, let us consider just how old the ocean is. The ocean is approximately 3.8 billion years old. It formed in the first billion years of Earth's history, from water vapor released by volcanic activity and from water delivered by comets and asteroids in the early solar system. As the Earth cooled, the vapor condensed and fell as rain. Rain that fell for perhaps millions of years, filling the basins of the young Earth until the first ocean formed. Life began in the ocean. The first living cells appeared in the ocean approximately 3.7 billion years ago. Single-celled organisms living in the warm, mineral-rich waters near hydrothermal vents or in shallow coastal pools. For more than 3 billion years, all life on Earth was marine. The first animals evolved in the ocean. The first complex multicellular life appeared in the ocean. The first creatures with eyes, with mouths, with nervous systems, with skeletons. All of them were ocean creatures, living and dying and evolving in the dark and the light of the ancient sea. When the first creatures ventured onto land, roughly 375 million years ago, they carried the ocean with them. The fluid that surrounds our cells, the fluid in our blood, is chemically similar to seawater. We are, in a very literal biological sense, creatures of the ocean who have not entirely left it behind. The sea is still inside us. The whale, which is one of the ocean's most magnificent inhabitants, is descended from land animals, hoofed mammals that returned to the sea approximately 50 million years ago. The front flippers of a whale, if you examine the skeleton inside them, contain the same bones as a human hand, the same five-fingered structure, modified over millions of years of evolution for a very different purpose. A whale's flipper and your hand are built on the same blueprint. We share a common ancestor with the whale. We are cousins, separated by hundreds of millions of years of evolution. One of us returned to the sea, the other stayed on land. And yet the whale still breathes air, still nurses its young with milk, still carries the warm blood of the mammals we both came from. The ocean gave us all to each other. It is late now. The light is long gone. Somewhere out in the dark ocean, a blue whale is moving slowly through the deep water, its vast body weightless in the sea, its heartbeat slow and steady, its breath held for another 20 minutes before it rises again to the surface to exhale and breathe and dive back down. Somewhere, bioluminescent creatures are trailing cold light through the midnight zone, their soft glows flickering in the dark, like stars seen through deep water. Somewhere, a sea turtle is navigating by magnetic fields across hundreds of miles of open ocean, guided by a sense older than sight, heading toward a shore it has not seen in years. Somewhere, the marine snow is falling, slow and continuous, drifting down through thousands of meters of dark water toward the soft sediment of the ocean floor, carrying with it the remnants of the sunlit world above. And somewhere, just below the surface, a kelp forest is moving gently in the current, its long fronds swaying in the slow, deep rhythm of the sea. The ocean has been doing all of this since long before there were eyes to see it, or ears to hear it, or minds to wonder at it. It will be doing all of this long after tonight. There is something deeply comforting in that. Something that makes the smallness of a single night, of a single person lying quietly in the dark, feel not diminished, but held, contained within something vast and ancient and endlessly, quietly alive. The ocean is still out there. It is breathing. It is full of light that no one sees, and sound that travels for thousands of miles, and life in forms we have barely begun to imagine. And you are made of it. Every cell in your body carrying the chemistry of the ancient sea, the memory of a time when all life was ocean. Rest now. The tide is coming in somewhere, and the water is warm, and everything is slow and deep and blue.